Hi everyone, I am Misan Shayun, an electronics engineer in Bilkent University. In Physics 101 project, I carried out an experiment showing that conservation of energy in simple harmonic motion. The mechanism you have seen, you see a spring, ruler, an object. We see that when it releases from a certain distance from the balance point, it behaves in simple harmonic motion. During simple harmonic motion, energy is stored as potential at the extreme points, while it is stored as kinetic energy after at the equilibrium measurements were made with a slow motion camera. I first calculated the speed at the balance point. While making this calculation, I used the ratio of position change to the time formula and set my position to constant, which is 4 centimeters. After this table, I measured the downward oscillations. I repeated it 3 times for 3 different experiments and calculated the averages so that I could reach the most accurate result. For the first experiment, I dropped the mass 10 cm away from equilibrium point. The system gained approximately 0.05 joule, as you can see in the table. For the second experiment, I dropped the mass 15 cm from the balance point, and my total energy is approximately 0.9 joule. Finally, I dropped the mass 20 cm away from balance point with 0.15 joule. As you can see in the plot, the orange lines show that potential energy, the blue ones shows kinetic, and the gray one shows total energy. When we follow the blue and the orange lines, we can clearly see that energy is preserved by changing form. When we look at the gray graph, we can make our comments on the errors. We see that there is a decrease at the midpoint. This occurs precisely because we take the average velocity around the equilibrium point, not the velocity at the equilibrium point. The reason why the error rate we found in the first experiment was higher than the second ones, probably because the moment occurred in the shorter oscillation. In the third experiment, since the moment is occurred quickly, it became difficult to make the actual measurement and the margin of error increased. We can see that the energy is conserved in total for all experiments. Over time, the total energy decreases with the friction force and will turn into heat and disappear. When we examine plots of all 3 experiments, we can clearly see that total energy is conserved by changing form in simple harmonic motion.